I don't like the fractions here. I could clean out the fractions by multiplying through by a least common denominator right now, or I could do substitution right off the bat, and I think I'm going to go that route. I've got an x equals, substitute that into the top line. So we're going to have 1/3 times input plus y equals 7/3. And the input here is 3/2 y minus 11. So let's do some distribution there on the left. First off, when we do our first multiplication, the 3's cancel, just leaving 1/2 y minus 11/3 plus y equals 7/3. Now I don't like the fractions here. I could multiply through. I'm actually still going to add 11/3 to both sides. That's going to be kind of nice. Because doing that, I'm going to have 1/2 y plus y equals 18/3, and 18 divided by 3 is 6. So that's just a nice clean 6. I think instead of avoiding these fractions, I'm just going to write this in decimal form. 1/2 plus 1 makes 1.5 y is equal to 6. Divide by 1.5 and get a nice clean 4. Substitute that back in. Maybe something you don't want to do, but we can do that. Let me move this over a little bit. We're going to get x equals 3/2 y, that's 3/2 of 4, minus 11. Now that 4 really is a 4 over 1. So if we cancel on the diagonal, we get a 1 and a 2 there. And so we get 3 times 2, that's a 6 minus 11. And so x equals -5. Okay, the last problem of this review. Tina bought 3 adult tickets and 1 child ticket to a movie. Again, it sounds like a mixture problem. We're mixing together adult tickets and child tickets. So 3 adult tickets and 1 child ticket. Okay, numbers of tickets. 3 adult and 1 child. Those are the numbers of tickets. Cost $23. We don't have the price. I'm going to use A for the price here and C for the price there. Then Lisa, reading the second sentence here, Lisa bought 2 adult tickets and 5 child tickets and spent $30.50. So I really have 2 equations here. Top times bottom, 3a, plus top times bottom, 1c, is equal to 23. That's my first equation. My second equation, top times bottom, 2a, plus 5c, is equal to $30.50. So there really is the start of this problem. Now that we've got it all kind of lined up, we can either use substitution or elimination. I'm going to do something different this time. I'm going to say C is equal to 23 minus 3a and substitute C into the other equation. That other equation becomes 2a plus 5 input of C equals $30.50. My input here is 23 minus 3a. We're going to do some distribution on the left side of the equation to see what happens. We have 2a plus 115 minus 15a equals $30.50. We're going to want to combine like terms on the left, and I'm going to do 2 steps at once here. I'm also going to subtract off the 115 on each side. So 2 minus 15 gives us negative 13a. On the right, when we subtract, we're going to have more negativeness. And so I'm going to subtract in the other direction. 115 minus 30 takes me down to 85. This will be 8450. Then I need to divide each side by 13. I think I'm going to need to do some long division here. So off to the side, 84.5 divided by 13. That goes in about 6 times, making 78. Subtract and get 6. Bring down the 5. That goes in 5 times. It looks to me like I got an answer of 6.5, which would mean $6.50 for an adult ticket. Now we need to figure out, substituting back into one of these equations, I think what I have in red there is where I'm going to go. A child ticket is going to be 23 minus 3 of these adults at $6.50. That'll be 23 minus $19.50, and therefore the child ticket is going to be $3.50. Adult tickets for $6.50, child tickets for $3.50, and there we have it, the end of our Chapter 3 review. Good luck on your test, everybody.